Okay, so let's look into this homogeneous catalyst mechanism. Even homogeneous catalyst or heterogeneous catalyst, the intention of using this homogeneous catalyst or heterogeneous catalyst is for the reduction purpose. So reduction of olefin, that is alkene system, that is catalytic hydrogenation, we will call it as. In presence of this catalyst, you can reduce the olefin into the corresponding alkene system. So now the question is, what type of mechanism generally it involves in case of homogeneous catalyst? If you're using a homogeneous catalyst, so how usually the reduction reaction takes place? This is a general mechanism. Whatever may be the homogeneous catalyst, if you're using for the catalytic hydrogenation purpose, then mechanism is most of the time it will follow with this type of step of mechanism only. So homogeneous catalyst mechanism generally involves four major steps. The step one is the binding of hydrogen to give a dihydral complex. The step one is the binding of hydrogen to give a dihydride complex. Generally, this step is, we will call it as an oxidative addition. So the process is oxidation and then followed by addition to the system, which leads to the dihydride complex formation. Let us see the L, N, and M. So L is the ligand and M is the metal. And you're using H2 source. In the step one of the reaction, these two combine, L and M and plus H2. You will get a complex of dihydride complex. So that is LNMH2. So as this step involves some oxidative addition because the change in the oxidation state in the metal occurs during the addition of H2 to the LNM. And you will get in this type of dihydride complex LNMH2. And the process is some oxidative addition because some two molecules adds up to get in one single molecule. During the process, oxidation state of the metal will increase. That's why oxidative addition. Next, as soon as this step one is formed LNMH2, that is dihydride complex formation. Next comes is step two. In the step two of the mechanism, the binding of alkene means as soon as this dihydride complex is formed, then alkene source. This is the site of reduction site. Alkene, you need to convert it into alkane. So the binding of alkanes to this dihydride complex will occur. So the equation will be then LNM n square H2. N is the number of integers. Suppose you can use 1 equivalent, 2 equivalent, 3 equivalent like that. LNM n H2 plus CH2 double bond CHR. So let us assume this is an alkene you are using. So you can use any type of alkane system for the reduction. As it is a general mechanism, let us assume that the CH2 double bond CHR you are using as an alkene system. And the dihydride complex is formed in the first step of the reaction. So as soon as these two react, you will get an Ln minus 1. Carefully look into this. Ln minus 1 MH2 and CH2 double bond CHR. That means one of the ligand LNM, the one of the ligand which is present in this dihydride complex has been substituted by the incoming alkene system. So that's why as it is one L has been substituted, this number should be N minus 1. So compared to this stage, it has one ligand less compared to the starting dihydride complex. Ln minus 1 MH2, the CH2 double bond CHR, that is the binding of this alkene into the dihydride complex, along with that knockout of one of the ligand system. Next is step 3, the transfer of one hydrogen atom from the metal to carbon, that is migratory insertion, we will call it as the migratory insertion. Now take this Ln n minus 1 MH2, the CH2 double bond CHR. Then during this the migratory insertion step, so as it is that there are the H2 is already present, So H2 addition is taken place in the step 1. Then one of the hydrogen atom, as it is two hydrogen atom, one hydrogen atom transfers across the C double bond C. Generally, the hydrogen will first hydrogen will adds to the carbon, which is having the less hydrogen in the initial stage. So first hydrogen has been transferred, the CH2, CH2, single bond CH2R. And still you have left within one more hydrogen atom. As it is, only one hydrogen atom has been transferred across the C double bond C. One hydrogen atom is still present, and along with that, the one hydrogen atom has been adds to the carbon. Now this some earlier this is carbon has the one hydrogen, one R group, and C double bond C. Now it has been converted into single C carbon carbon single bond and two hydrogen atom and R. So this type of step is we will call it as a migratory insertion. Next is step 4, the transfer of the secondary hydrogen atom from the metal to the alkyl group with simultaneous dissociation of the alkane. Reductive elimination, we will call it as. That is the step 4 of the mechanism, transfer of the second hydrogen atom. Because in the step 3, the first hydrogen atom has been transferred across the C double bond C. The step 4 involves the second hydrogen atom from the metal to the alkyl group with simultaneous dissociation of alkane. So in this step 4, so the simultaneous transfer of hydrogen across this particular carbon, as because one hydrogen has been already occupied over this particular carbon. Now this H2 will receive an hydrogen and which will comes out as a reduced substance, and you will get Ln minus 1 M, because this has been hydrogen has transferred over this carbon and it tries to come out as an alkane, and you will get the Ln minus M as the catalyst after the step 4 of the reaction. Now, if you look into this, these four steps, when usually olefin is entered or alkene system is entered during the reaction mechanism, which step alkene is introduced during the catalytic hydrogenation?
Second step.
Second step. H2 has been introduced in the hydrogen. In which step we are introducing H2?
First step itself.
First step. The first step, generally, the catalyst, homogeneous catalyst, interacts with the H2 and you will get an dihydride complex. That is oxidative addition, we will call it as. So the step 1 is oxidative addition. Step 2 is the binding of alkene. The binding of alkene will take place with the already formed dihydride complex, and knocking out of one of the ligand, as it is, we are using one equivalent of the alkane source. Ln minus 1 MH2, then CH2 double bond CHR plus some, along with that, one ligand has been replaced. In the step 3, the transfer of one hydrogen atom from the metal to carbon, that is migratory insertion. One hydrogen has been adds to across the C double bond C, and still one hydrogen is having interacted with the metal center. In the step 4, the transfer of the second hydrogen atom from the metal to the alkyl group with simultaneous dissociation of the alkane. So during this step, the hydrogen will be transferred and then alkane has been released out of the metal catalyst. That is reductive elimination, because reduction step as well as elimination step is taking place. That is reductive elimination. So, is it clear with respect to the general mechanism of homogeneous catalyst? How usually the catalytic hydrogenation um, in presence of homogeneous catalyst based reactions. Thank you for watching the videos. For more videos, visit us on www.chemlearner.com. Thank you.